You guys see the radians and the degrees are all there, right? So just refresh me on that unit circle. 2 pi over 3 radians, what's its equivalency in degrees from that chart? 2 pi over 3 radians, what's its equivalency?
Oh, 120.
120 degrees. Now, just a quick reminder on how we do this. If I'm going from, say, maybe a certain number of radians to maybe I've got, I don't know, I want to go from radians to degrees. On that chart, 2 pi over 3 radians is how many degrees again, kids? Did you say 120? Is that what you said, Noah?
Yeah.
So you simply just multiply by 180 over pi. So to turn radians into degrees, you would multiply by 180 over pi. I don't know if you need to jot that down again or not, but just a quick refresher. What do the pi values do to each other here?
Cancel each other out.
So how about the 180 over 3? What is that?
Certainly a number.
60 in that case, right? And then 60 times a 2 puts you at how many degrees?
60 times 2, that's 120.
So it puts us right there where we need to be, 120 degrees. So that's an important piece of information here to keep in mind when we're doing that. So don't lose sight of that. If you're turning radians to degrees, you would multiply by 180 over pi. What if I was going the other way again? What if I was going from degrees to radians? You remember that? Anybody recall that?
Divide by 180 pi.
Divide by 180 over pi, which would be the same as multiplying really by the reciprocal of pi over 180 there. So maybe jot those down. If you're going radians to degrees, multiply by 180 over pi. And this might help you with the things that we're going to do here today. And if you're going degrees to radians, times pi over 180. Now, if you notice, when we got done with the vocabulary yesterday, the vocabulary right after that it said assume what type of units for everything. It said assume radians, didn't it? So, right here on this next example where we're at, we need to determine the trig characteristics. Here it says determine if the sine, cosine, and tangent are positive, negative, 0, or undefined. Okay? Now, take a look right here, guys. 3 pi over 4. Maybe one of these angles is listed on your unit circle. Maybe it isn't. But here's what I would tell you. If you weren't sure, unit circle is broken into 4 quadrants, isn't it? And we talk about 2 values that are up there. Now again, this horizontal value was the cosine value of the unit circle, and the vertical value was the sine. So guys, in the first quadrant, both the cosine and the sine are what type of values? So I would have a positive cosine and a positive sine in the first quadrant. How about the second quadrant? What's the cosine in the second quadrant? Is that negative? So my order on this for cosine comma sine would go negative comma positive. Down here that'd be negative comma negative, and positive comma negative. Now keep in mind, kids, this order is based upon cosine being the first value listed, and then the sine value being listed. So quick question for you. Again, it says when they throw this up here, and for the things that we're going to do, assume radians, but sometimes radians gets confusing for me, especially when I don't know where it is, especially if it's not listed. So here's the question I would pose to you. Is 3 pi over 4 listed as one of the radian values on your unit circle?
Yeah.
It is?
Yeah.
Which quadrant does that fall in?
That's
So I'm just going to make a note up here and say, oh, this is a nice one. This is a nice one. This falls in quadrant number 2. So by quadrant number 2, what must the cosine value be? How about my sine value?
Positive.
Now, there's nothing listed up there for tangent, but we talked about this idea of tangent being the ratio of the two previous functions, cosine and sine. What's another definition for tangent in terms of sine and cosine? Look at your first page. We said tangent might be equal to something over something. Sine over cosine, right, Belle? What do I have as a sine value? I'd have a positive sine over a negative cosine value, right? Or a positive over a negative, if I want sine over cosine. So what's that mean about the tangent within the second quadrant? Or what about that tangent value at 3 pi over 4 radians? What is it?
Negative.
Gotta be negative, you bet. Okay. All right, kids, where the heck is 3 pi? Let me ask this question. How many radians are in one full revolution?
2 pi.
2 pi. Doesn't 3 pi exceed 2 pi?
Yes.
Okay. How many degrees are in one full revolution? 360. I don't know how you guys roll. It's okay. What I will say is this. If you weren't sure, couldn't I turn this to degrees right away? I could multiply this by 180 over pi. What are the pi values going to do to each other, kids?
Cancel.
What's 3 times 180? Isn't that 540 degrees? But is 540 degrees an option on your unit circle? Is that one revolution or more than one revolution?
More than one.
So if I want to figure out where I'm at, how much could I subtract to get to where I want to be on the unit circle? Subtract the 360. Take a revolution out of that. You bet. In which case this turns out to be how many degrees, kids? 180. Or think about it. What's 3 pi minus 1 full revolution of 2 pi? It's 3 pi minus 2 pi for a whole revolution. It's 1 pi. Doesn't pi and 180 match up on the unit circle?
Yes.
Okay. Talk to me, kids. What's the cosine value there? Negative 1. So it's negative. How about the sine value there, Belle? 0. Okay. Careful on the tangent, kids. I thought I heard somebody say something. 0. Yeah, 0 divided by a negative. Sine over cosine. 0 over a negative would be what type of value? Well, it would be 0. Okay. All right, you guys try these two on your own. I might say turn them to degrees first, manipulate them a little bit, see which quadrant you fall in, and then answer the question. So I'm going to give you a couple minutes. I want to know what the sine, cosine, and tangent values are for those last two examples. Keep in mind that 6, is that 6 degrees or 6 radians? And be careful, it's not 6 pi radians, it's 6. Okay, what'd you guys come up with for negative 5 pi over 3? What'd you guys come up with there?
What do I say? Positive cosine, negative sine, and then negative tangent?
How many agree? How many have something different? What'd you have?
I had them all positive.
All positive? How many had all positive? Okay. Let's talk real quickly. This negative 5 pi over 3 is a little confusing. I'm going to be honest with you. I like to turn stuff to degrees. Now, is 5 pi over 3 an option on your unit circle? That's my first question.
Yes, it is. At 300 degrees.
Yeah, so 5 pi over 3 would be like starting this way and going 3 quadrants this way, right? So 1, 2, actually 4, right? So wouldn't negative 5 pi over 3 go kind of the same way? Went through 1 hole, 2 hole, 3 hole, and stop here, right? So really wouldn't go in negative, the opposite, go 1, 2, 3 hole, and stop in the fourth one. If I was going in the negative direction. So what quadrant would that stop in?
Quadrant 1.
Quadrant 1, meaning what there, Noah?
Everything's
All
positive.
right, so yeah, everything is awesome. All right, I'm going to check, maybe if I turn it to degrees. Pi's would do what here, kids? Don't they cancel? What's 180 divide 3?
60.
60 times the negative 5 would equal,
300.
the negative 300 really isn't accounted between 0 and 360, so maybe I add a whole revolution to this that would put me at 60 degrees. Kids, 60 degrees being which quadrant?
Quadrant?
Quadrant 1. All of these are what?
Positive.
Positive. Okay, I want to do something for you guys to help you out. You guys have your unit circle? Up here this says pi over 2 radians, right? Does that make sense? Up top of your circle's pi over 2 radians. Write this up here above this. Just write it in. Pi over 2 radians as a decimal is about 1.57. Okay, so you might want to write this in. Pi radians over here is really about 3.14 radians. This down here, this down here is about 4.71 radians, and a full 2 pi radians is about 6.28. 2 times 3.14 is 6.28. Now, one way to think about that 6 radians right there, kids, well, if I have this 1.57 radians, 3.14, where is 6 radians going to fall, kids? Which quadrant? 1, 2, 3, or 4? Based on these values, where would 6 fall between? Down here. Now, again, I'm telling you, if you don't have a clue where 6 radians falls, turn it into what? Turn 6 radians into degrees. Who's got a calculator handy? Let's punch this up for me. Val, you gonna save me again? 300 and how much, Colton? Something like that. I like 340, I think it's 343. Double check that for me, Belle.
I did something wrong.
343. Okay, so 6 times 180 divided by pi. Where's 343 degrees gonna lie, kids? Quadrant 4. In which case, how about the cosine? How about the sine? And how about their tangent then? Yeah. Can you guys handle those? First question, can you handle those? All right. Well, let's get rocking and rolling here. This is the good stuff. Example 2. Any questions about what we just did up here? Thumbs up if you're okay. Good? Awesome. Suppose that we have a trig function. Again, the assumption is that we are in what, kids? Radians. I'm just going to go ahead and graph this real quickly. Okay? I'm going to graph this real quickly. First of all, what's our parent function? Which trig function is our parent function?
Sine.
Okay, I'm going to jump into decimals real quickly for this. Let me get this and this gone. All right. In decimals here, kids. We are in radians. Okay, I'm going to graph the sine function. Y equals sine of x. There's our graph. Okay. So I've got 0.00, pi over 2 comma 1, pi comma 0, and so on. Now, kids, what are we supposed to graph here next? What function are we working with?
It's 3 sine 2x plus 2, and then outside parentheses, plus 4.
Okay, what effect does that 3 have right there, kids?
Raises the amplitude.
Raises my amplitude up there, okay? So it vertically stretches it, in other words. And then you said 2x plus 2, is that right? Okay. What does the 2x plus 2 do to it?
Horizontal shrink.
Horizontal
And then
shrink, yep, it compresses it, doesn't it?
Translation to
Okay.
that.
Yeah, let me get this. Let's gotta be careful on this one. Okay. I'm gonna remember this point right here. Pi over 4 comma 3. I go plus 2. This is now at about negative 0.215. We'll talk about what that looks like here in a second. But what's the last part of this?
Plus 4.
What's this plus 4 going to do for me now, kids?
Horizontal or vertical translation up.
Yep, translates it up, okay? Here's what we're working with, all right? So, in your notes here, kids, I want you to look at what we have here. Down here we have amplitude, period, and phase shift. And if you go to the next page here, I don't know if it's on here or not. And not quite. Okay, I'm going to go back here. I want you guys to write this down at the top of this. All right, we have to find the amplitude, the period, and the phase shift. And I want to put some rules down here, okay? Your amplitude is going to be the A value that's out front. It's the absolute value of the A value. So let's get a general form written up here. Most functions here, kids, that are written for a trig function where we might have y equals, I'm going to say A, and then in this case I'll use sine of bx plus c plus a d out here. Your amplitude typically is the absolute value of the A value. Right? Your amplitude is typically the absolute value of A. So basically it's saying if you had a midline there for that sine function or cosine function, what would the amplitude be? How far above that midline is the peak, and how low is the trough there? So what is the amplitude in this problem, kids? It's 3. Okay? It's 3. Okay? It is going to be 3. So the amplitude here, oops, I need to turn that on. There we go. Okay, the A value up here is 3. Now, in finding this right here, your period, kids, your period. Anybody know what the period's equal to? All right, doesn't matter if you don't. Here's the situation. If I go back to my graph, take a look at this graph right here. If I start following around here, do you guys agree that if I start here, I go all the way up, all the way down to the lowest, and then back? This is where my graph starts over at right here, starts repeating itself. For just the function sine of x, what's the length of one period? In other words, how long to go complete one whole cycle?
2 pi.
2 pi. Now, up here, if I go from a peak all the way down to a valley, back up to a peak and start repeating, we need to know how much that changes by, okay? So, the absolute peak is negative 0.215 for an x value. We cycle all the way down, all the way back up to where we were. All right, who has a calculator for me? Belle, can I have you punch this in? Go 2.927, that's the x value at that peak. And then minus, let's back up to this. That negative, so minus negative 0.215.
3.142.
Pi, right? Okay. So kids, here's the deal. If you remember correctly, your period or your cycle time is found by taking 2 pi and dividing by the absolute value of b. So we talked about that too, was going to compress it, and here's how it compresses. It just says, well, the period here in this case would equal 2 pi divided by the absolute value of b. What is the b value in this? 2 pi divided by 2, so the period time, or the amount of time it takes to cycle through one whole part of the graph would be pi radians, okay? That there's going to equal your period. Then a phase shift, how far left or right? Well, phase shift, anybody know how to find phase shift? Say that again. The opposite, well, you're close. Somebody from Trig remembers this. Gabriel, you remember? Phase shift? Bell, you remember?
It's not ringing a bell.
Noah, you remember?
No. I said that as an accidental pun.
That's a good one. You walked right into that. Sometimes you walk right into it. That's good stuff. Okay. So let's talk about this phase shift that's in here. Let's just let's maybe do this. Let's maybe take the 3 that's out of this. So let me get back to my graph. Let's just maybe say there's a valley right down here that would coincide with maybe this valley right here, right? And then it got shifted up 4. So we want to know how far to the left is this. So kids, do this for me. Somebody punch 3 pi over 2 in there.
4.712.
Okay. So I'm going to get rid of this plus 4, because plus 4 is not going to change that, all right? And I'm going to get rid of this 3 right here. Did you say it was 4.71, Bell? Is that what you said?
Yeah.
And got to think here. This point would be 0 has been kicked back to here, basically. Okay, this point right here has been shifted over to this point right here. So 0 to, what's the distance there? Forget this 3 pi over 2 stuff. This actually is not going to help. I've got to go relative to the origin. So I've got to go this point shifted to the left, how many units? So if I look at my curve from here to here, like I looked at it from here to here, we got to understand where the zeros go. So this stays put, this point moves right over here. What is that value? From 0 over to -1, what is that value? What's changed? 0 down to -1, what's the change? -1, okay? Here's how you find your phase shift, kids. Your phase shift is just simply the opposite of your C value divided by your B value, okay? So in this case, it would be what over what?
It would be -2 over 4. No, sorry, that's a B. I meant to say 2. -2 over 2.
So really it goes left how many units? Goes left 1 unit, right? So things I want you to know. Reminders. How do you find the amplitude in a trig function? It's the absolute value of what?
A.
In this form right here. How do you find period?
2 pi over absolute value of B.
And then phase shift.
Opposite of C, right?
What's that?
Opposite of C, right?
Yep. Okay, so let's talk here. Let's move on to this third page here. This is the page I'm really worried about here. Writing functions. Writing functions for graphs. Here we go. It says write a trig function for the given graph oh boy, there's 2 examples here. First things first, kids. Does this graph appear to be a sine graph, or look at where it starts at? If you looked at your first page of notes, which graph starts at the origin? Sine does. So this appears to be a sine graph, doesn't it? Okay. Where does your cosine start? We drew a different one in here. Cosine doesn't start at 0, 0. Cosine starts at 0, 1. And we drew that in there yesterday. So this appears to be what kind of graph then again, Belle? What'd you say? Sine? Okay. So I'm going to start this out as y equals the sine, or I'm going to back up, a times the sine of bx plus c plus some distance d. And my job right here is to find values for a, b, and c and d to put in, and then when we put them in, graph that in decimals and see if it matches. Okay? So how about your amplitude, kids? Do you know the amplitude of this graph? How much? 5. Now would I have a positive 5 or negative 5 in here? It'd be a positive 5 actually, because it starts by moving up. Now if this sine curve started by moving this direction, kids, then what would you have said?
-5.
Negative. So you got to keep in mind the way the function works. So it is a plus 5 sine. Okay. I have a question, kids. What does b affect? Well, if I go back here, don't we use b to help us figure out the period? We Would you agree with that?
Yes.
Okay. So the period is defined as 2 pi over what here, kids? Okay, 2 pi over absolute value of b. All right. Well, let's talk here quickly. Guys, first of all, how long is my period? Looks like I go from a low, so here, all the way to the low, all the way to the top.
6 pi.
Okay, so this would be negative 1 pi, 2 pi. So okay, so if I understand you correctly, Noah, you said the period is how long again?
Looks like 6 pi.
So my period is equal to 6 pi, meaning 6 pi has to equal, what's the formula for period again, kids?
2 pi over absolute value b.
So I'm just going to put 2 pi over b here, right? If I multiplied both sides by b, wouldn't this be 6 pi? B is equal to 2 pi. Would you agree with that? Agree with that? So to get b alone, what would I have to divide both sides by? To get b alone, I'd have to divide both sides by
6b.
actually 6.
pi.
Yeah, there you go. Okay, these are gone. I've got b equal to 2 pi over 6 pi. What are the pi's going to do?
This would be here.
2 over 6 would be what value, kids? 1/3. So I'll put 1/3 x in here. Okay. How about any shifting for this point right here? Does this point right here shift left or right at all? This point's still going through the origin for sine, right?
Yeah.
Okay, so what's that mean C has to be then?
0.
0. Okay, so we can say 1/3 x. Did this point move up or down at all? So what's that mean about my d value? So, okay, we think our function is what then, kids? Should we try and see if we're right?
Or it could be any C could be any multiple of 6 pi.
Let's try this. I'm going to jump back in over here. Does that match our negative 3 pi in the graph that we had? Is our amplitude up here 5? Like that? Looks like we're 5 up and 5 down. Goes through 0, 0. Does it hit 3 pi on our graph? Do we have the right one? Okay. So, let's see if we can't look at something that's maybe a little more complicated than this. Okay? No graph. How about volunteer read the top right for me?
Write an equation of a periodic function with amplitude 20, vertical shift 30, period 2 pi, and horizontal transition. Phase shift 6 units to the right.
Oh my gosh, Belle. And I did a poor job of writing this problem. Should we write, what periodic function you want to use? You want to use sine or cosine, kids?
We have done cosine.
Let's do cosine. Let's say a periodic function. Let's say we were going to use cosine with this one. I didn't write that in there. I should have. Okay, so we're going to use cosine for this one. So we're going to write something of the form y equals a cosine of bx plus c plus d. Okay? All right. You guys are going to talk me through this. Any ideas on this right now?
Alright, amplitude is 20.
So I know A is equal to what value? Right off the bat.
20.
Okay. Okay. Let's deal with that vertical shift. Vertical shift would be applied through which variable up there? Which one shifts our graph up? The D does, right? So D has to be what?
Then, let's see.
All right, so we have a period that's what?
2 pi.
So my period of 2 pi, then, I'm going to make a little chart here like this. 2 pi has to equal 2 pi divided by B, doesn't it? So what's that make the B value here?
Makes it 1.
Yeah, B would just be 1. 2 pi divided by 1 would be your 2 pi over there. So from this, B equals 1. So we've got 3 parameters. So we've got this. We've got this. What do we need to find yet? Okay, and C is going to affect what?
6 units.
Okay. So 6 units to the right. So my phase shift is going to be a 6. Phase shift, I'm going to write this down here. Can I write PS as phase shift? Is that okay, kids? What was the formula I gave you for phase shift in these types of functions? Okay, so what was the phase shift again, kids? B is 1, isn't it? So wouldn't that equal the opposite of C over 1? So if I solve this, isn't that like saying 6 is equal to negative 1C? Guys agree with that? 6 is equal to negative 1C. What's that make C in this situation? Negative 6, yep. Okay, so let's check this. We believe that when we're all done with this, that our function should be y equals what's going in for A, kids? Or you guys tell me what the function is when you've gotten it written. What trig function is going to come after 30? What do we decide on?
Cosine.
Cosine of, all right, bx.
B is 1, so it would just be x.
X plus c, so minus plus what? I'm just thinking about this, kids. Doesn't this 30 imply amplitude of 30 right here? Think about x minus 6. What's the idea of x minus 6 going to do in terms of movement? What direction? Well, minus 6 would be right, wouldn't it? Right how many units?
You accidentally wrote amplitude 30 instead of 20.
Oh, yeah, I did. Perfect. Thanks, Noah. Good catch. Let me fix that here quickly. So instead of 30 cosine x, we should have... All right, thanks. Good. Appreciate that. 20 cosine x minus 6 plus 30. Okay? I wondered why no one was talking to me earlier. You guys were just letting me be wrong, weren't you? How do you feel about this?
You said it wrong.
Probably.
Really?
You guys okay with that? Okay.
Yeah.
Last example. Let's try it. See if we can get through this, figure this out. At high tide, the water level is 14 feet below a certain pier. At low tide, the water level is 26 feet below the pier, assuming sinusoidal behavior just simply means it's either a sine or cosine graph. Sketch a graph of y equals f of t equals the water level relative to the pier, t hours, if at t equals 0 the water level is negative 20 feet and falling until it reaches the first low tide at t equals 3. Based on your sketch and information provided above, write me a formula for f of t. Ooh boy. Don't worry about this right here. Okay? I don't really care about this right here. Get rid of that mess. And this mess right here. Okay. High tide, where's that at? 14 feet below a certain pier, right? So what value would that be? I'm talking 14 feet below, what value is that going to relate to?
Negative 14.
And let's see. At low tide, the water level is how many feet below the pier? Okay. So we're walking on this pier out here. High tide is 14 feet below that. Low tide is 26 feet below that. Okay. So we know the highest that it's going to be is 14 feet below the pier. The lowest it's going to be is 26 feet below the pier. Okay. It says at time t in hours, if t is equal to what? Time t is what?
0.
The water level is where?
Negative 20 feet.
And doing what?
Falling.
Okay, so negative 20 would start right about here. All agree? And it's falling. And now when it gets to the lowest low, it starts to do what?
Starts to rise, I imagine.
Okay. So let's just say this is the lowest of low points right here. It said the lowest point happened at t equal to what, kids?
T3.
At 3, right? So this means that this time right here corresponds to 3 hours. Okay, so if it went from negative 20 to negative 26 in 3 hours, how many hours is it going to take to get back to negative 20?
3.
Another 3 hours. And then it's going to start doing what?
Starts to rise up.
Starts to rise up, okay? The tide likes football. It's rising up. What time is this high tide of negative 14 feet below the pier going to be? How many hours? Be careful on that. Yep, because here it's at 0, 3 at the lowest, 3 to get back to negative 20, and then another 3 to get to high tide. So what time is this again?
9.
And then finally it comes back and starts right about here, gets back to that negative 20 line. How long is one cycle, kids? Or one period, if you will?
12.
12 hours. Okay? Given what I've given you there, I'm going to ask you guys to write me a function for that before we take off. So take a couple of minutes. Write me a function that models this. Hey, does this look like a start of a sine curve or a cosine curve?
Sine.
Looks like the start of a sine curve. Right? See what you come up with for this, all right? Careful on the direction of it. Anybody have a function written?
Got a -6.
Whoa, -6. Okay. We haven't dealt with negatives. Why negative?
Because it goes down
Yes, direction starts downward instead of what?
upwards.
Okay, why 6?
Because that's its amplitude.
Yep, 6 from the peaks and the valleys. So, all right, I'm listening. Y equals -6
Sine, of course.
sine. All right.
2 pi over 6. Wait, did I make an oopsie? I believe I've made an oopsie.
Okay, so the phase, or you're talking period right now, right?
Yes.
So your period, which would be
Oh, I accidentally used that. There. It would be.
Is it 0.524?
maybe. Let's check this. Doesn't 2 pi have to equal? Doesn't I
Is it
period?
pi over 6 then?
Maybe. I'm not even sure. That's the formula for period right there, right? How long is a period over there?
12.
Okay. I sometimes like to set this up as a proportion. I kind of like to set it up as 12b equals 2 pi. Is that okay? And then now, Belle, what did you say your decimal was?
0.524.
I think that's going to be right. Because this reduces to pi over 6, doesn't it? And that's what you said, right, Noah?
Yes.
And I like that. I would be very happy if I saw that in there for that b value. Run pi divide 6 for me. Is that the same thing, Belle?
Yeah.
Awesome. So I don't care if you go decimal form because, again, saves the process-wise, you did the right thing. You all right with that? Okay, so I'm going to use pi over 6. That's probably what you would see. Okay, how about a phase shift? Did this point move left or right at all? From the origin, did this move left or right? No, so is there going to be a C value? No. How about a vertical shift at all, though? Did this point move from the origin downward? To where? Minus what? Where did this move to?
-20.
Minus 20. You bet. There it is. There it is. F of t, or in this case I called it y, would be -6 sine pi over 6. And I should honestly, instead of using x, I should be using what variable right here? Everything was relative to what? T. Yeah, so I should probably change that and call this T. All right. Questions for me at all, kids? All right, good place to stop. I'd say tomorrow we might have a little bit of time to work on some things.